Hello everyone, welcome to my channel. In this video, we're going to solve this given exponential equation, 3 to the power of x plus x equals 30. And we're going to solve for the value of x. And some of you guys might say, hey, this is kind of easy problem, right? By inspection, we can say that value of x is 3 right away, right? But what about having a solution to that? How do we solve this kind of equation? Well, so in here, we'll show you a step-by-step way of solving this equation. Alright, so let's start with moving the x to the right-hand side of the equation. So, 3 to the power of x equals 30 minus x. So next, divide the whole equation by 3 to the power of x. So this is 1, and the right-hand side, 30 minus x times 3 to the power of negative x. So this is from the exponent property. If we have 1 over m, this can be written as m to the power of negative 1. We're taking the denominator, putting it to the numerator. We'll end up having the exponent being negative from positive. This simply means the exponent is 1, positive 1. So here we ended up with the exponent of negative x. So from here, let's switch the terms of the equation. So we have this now on the left hand side, 30 minus x times 3 to the power of negative x equals 1. Next step, we'll be multiplying the whole equation by 3 to the power of 30. And now you might be asking, hey, what the heck is that? We're multiplying the whole equation by 3 to the power of 30. Well, I'll explain it to you later. We'll get into that point. And so let's proceed multiplying it 3 to the power of 30, both sides of the equation. So this now becomes 30 minus x times 3 to the power of negative x times 3 to the power of 30 equals 3 to the power of 30. And if you notice, the left-hand side, 3 to the power of negative x and 3 to the power of 30, we can combine that. Based on exponent property, if we have a to the power of m times a to the power of n, we ended up adding the exponent, right? A to the power of m plus n. But since x is negative, we just subtract x from 30. And so here, 30 minus x times 3 to the power of, adding the exponent, right? Or simply subtracting x from 30. So 30 minus x. And the right hand side remains the same, 3 to the power of 30. And so from here, we're representing 3 in terms of e to the power of ln. Natural logarithm. So e to the power of ln of 3. And from now on, we're using this value of 3 here in terms of e to the power of ln of 3. So the left-hand side now becomes 30 minus x times 3 is now represented by e to the power of ln of 3. And since then, existing exponent is here, 30 minus x, let's write that over here. So e to the power of 30 minus x times ln of 3. And the right-hand side remains the same. Now from here, if you notice, we're seeing a pattern now, right? If you notice, this 30 minus x, and here the exponent 30 minus x, but it has natural logarithm of 3. Whereas on here, on the base, we don't have natural logarithm of 3. What should we do now? We multiply the whole equation with natural logarithm of 3 to make it even as that of the exponent of e, right? Alright, and then the question is, why are we doing multiplying ln of 3 to the whole equation? Well, we'll let you know in a minute. So for now, multiply the whole equation by natural logarithm of 3. So the left-hand side now becomes 30 minus x times natural logarithm of 3 times e to the power of 30 minus x, natural logarithm of 3, equals the right hand side 3 to the power of 30 times natural logarithm of 3. Did you notice something on the left hand side of the equation? 30 minus x, natural logarithm of 3, and the exponent here is 30 minus x times natural logarithm of 3. So from here, and so by using the Lambert W function, let's say if we have a term or expression expressed in, let's say, x times e to the power of x, integrating the Lambert W function principle to this expression, we get the value of x here, right? This one right here, x. Or whatever value of x right there will be. Like, for example, if we have, let's say, 7 times e to the power of 7, integrating the Lambert W function, we get the value of this expression as 7. That's the same way. All right, so in our equation, value of x here is this part right here, this expression right here, 30 minus x times quantity ln of 3. If you notice, this is x, the same thing, x again, this is the same thing, right? All right, so going back to our equation, integrating the Lambert W function to our equation, the left hand side we have w sub 30 minus x ln of 3 times e to the power of 30 minus x natural logarithm of 3 equals w sub the right hand side 3 to the power of 30 times natural logarithm of 3. And here, following this principle, Lambert W function, our x value here is this one right here. That's this the same way as this one, the exponent of e. Right? So now, left hand side, the value of x is 30 minus x times natural logarithm of 3. Whereas the value of the right hand side is w sub 3 to the power of 30 times natural logarithm of 3. And here, the right hand side can be written further as, or simplified further as, w times. Here we're separating 3 to the power of 30. We're splitting that into 3 to the power of 3 and 3 to the power of 27 times natural logarithm of 3. Why are we splitting this value of 3 to the power of 30 into 3 to the power of 3 and 3 to the power of 27? Well, if you notice in the next step, you will see, since we're integrating Lambert W function into the right hand side of our equation, we'll see what's going to happen next. All right, so right hand side, w sub 3 to the power of 3 times natural logarithm of 3, and here 3 to the power of 27, we can represent that 3 to the 27 can be written as e to the power of ln of 3 to the power of 27. So substituting this value of 3 to the 27 into e to the power of ln of 3 to the power of 27, representing 3 to the power of 27. All right, so the right hand side is now equal to w sub 3 to the power of 3 times natural logarithm of 3, and 3 to the power of 27 is now e to the power of ln of 3 to the power of 27. Simplifying further this right hand side of our equation, so 3 to the power of 3 is 27 times natural logarithm of 3 times e to the power of our exponent 27. We can move that to the front, right? Property of logarithm, right? So we have e to the power of 27 times natural logarithm of 3. And so here is still working on the right hand side of our equation. So this is simplified further as, if you notice, 27 times natural logarithm of 3, and the exponent of e is the same thing, 27 times ln of 3. What this means, by using the Lambert W function, we can extract the value of x here as 27 times ln of 3, right? Value of x, right? Like earlier from our formula. All right, so now the right-hand side now becomes 27 times natural logarithm of 3. And let's not forget our left-hand side of the equation. So we just bring that down. So this one, bring that down. So that is 30 minus x times natural logarithm of 3. Simplifying our equation, we can see that we can cancel natural logarithm of 3. So we have 30 minus x equals 27. Solving for x. So x is equal to 30 minus 27. So x is equal to 3. Our answer. And now let's check. And so from our original equation, 3 to the power of x plus x equals 30, substituting the value of x as 3. So this now becomes 3 to the power of 3 plus 3. Is this equal to 30? Well, 3 to the power of 3 is 27 plus 3 is equal to 30. So 30 equals 30. Simply means that x equals 3 is correct. So this is now our final answer. Thanks for watching, everyone. And so that's all for now. And for those new to my channel, I would appreciate if you can hit the like button and subscribe for more videos. I'll see you in my next videos. Have a great day, everyone. Take care. Bye-bye.